So welcome to the very last class of this class. I take it the last day of classes on Monday, but we don't have class on Monday, so this is it. This is the final meeting. And we're really just going to do review today. So I don't have any new material to present to you. We'll go through those sample short answer questions and talk a little bit about what ideal answers would look like. And then I'm just going to throw up lists of like key course terms, and we can talk about any of them that you want. There's probably too many to go through all of them in detail, but like we can hit some highlights and hopefully ask questions about ones that you want more info or something like that. And then maybe do one final argument analysis. Sound good? Any kind of course mechanics questions before we get into that? Yeah?
The argument analysis 2 is due tonight or not due tonight?
It is not due tonight. The deadline has been extended until December 4th at midnight, so the very end of December 4th. Yeah. Yeah. So yeah. I guess I should put up an announcement about that. I did say it in class, but I guess that's not reaching everybody. Okay. So yeah, I'll put up you all show up to class and therefore all knew this, but yeah. So yeah, you have a couple extra days to deal with that. Yeah? Anything else? Good. Okay, so let's talk about these short answer, because the bulk of the exam is just, there's 15 short answer questions worth 2 marks each. They're all of this kind of structure. None of these are actually on the exam, but like this is the kind of questions I'm going to be asking you. There's just a bunch of them. They all focus on what I hope are main concepts from the course. They all focus on things that were mentioned or listed in the key course terms. So that's cumulative, of course. So there's key course terms from test 1, test 2, and I put up another list for stuff since test 2. All right, so if you sit down with those lists and are able to explain all of the concepts on them in the style that we'll talk about here, you should be just fine. Also, and if you can do an argument analysis, but like, hopefully you've been practicing that in a wide variety of ways, so should be okay. Okay, so here's a typical question. Explain the concept of soundness. And you'll see like all of the answers that I'm going to show you are what I consider kind of ideal answers. These will all be worth 2 out of 2. And they all contain like more than one sentence for sure, more than 2 usually sentences. And they define the concept and then talk a little bit more about it. Maybe give an example kind of thing. So what we're looking for is evidence not just that you've memorized a definition, but that you understand the concept, right? Evidence, and you have to show us evidence, because the TAs don't know you as people. They don't know that you're smart, wonderful individuals that have been working hard all semester. They need you to actually show them evidence of that. Okay, so explain the concept of soundness. So a sound argument is a valid argument with all true premises. Now that's a definition of soundness, right? That first sentence is a definition of soundness. It picks out all and only the sound arguments, right? Come on in, we're running it casual today. Look, I didn't even tuck in my shirt. That's how casual we are. All right. Okay, so the first sentence there is a definition of soundness, but just defining the concept is not the same as explaining the concept, right? So that's good. That's certainly worth marks, right? Define the concept, tell me what it means, but then you probably have to do a bit more work to get the full marks. Okay, so in this one, a sound argument is a valid argument with all true premises. A person who just memorized that knows that sequence of words, but maybe doesn't know what they all mean. So one way that you can show me that that's not you, that you actually understand what you're saying, is to explain some of the concepts you use. Like valid argument is a concept used in that definition, so show me that you also understand the concepts that you're using. So define a valid argument is one where the truth of the premises guarantees the truth of the conclusion, right? So you've explained a little bit more about your definition, and then you say, so since sound arguments are valid and have true premises, its conclusion must also be true. And that's just giving like a little bit more info about the thing, right? You're drawing out one of the consequences of the definition that you've given. Alternately, you could give an example, right? To illustrate the concept. That would be another way of showing that you understand it. Yeah? Fairly straightforward? Okay, good. There's another one. So explain the difference between descriptive and normative claims. So We're just going to define them first. So a descriptive claim is one that simply describes how things are. A normative claim says something about what should be the case. Good? So those are just definitions of the two concepts. Sometimes I'll ask you about more than one concept in a short answer question. Quick definitions of both of the concepts, and then something more to show us that you understand the definition, like relating it to another concept in the course. In this case, I related it to ethical theories. Ethical theories are supposed to justify normative claims, and that's not necessary to say to define descriptive and normative, right? So you're going beyond what's just necessary to define these terms. You're relating it to something else because that shows me that you can integrate this concept with other concepts presented in the course. Okay? And here's another one. Hume's law says that normative conclusions require normative premises. Again, just taking another concept from the course and showing how it fits in with the definitions that you've given is demonstrating that you understand the concepts. Yeah? Okay. This might be a short class. I don't know how much we're actually going to have to talk about, but okay, so explain the difference between hypothetical and categorical imperatives. So, again, we define them and then elaborate a little bit to demonstrate understanding. Hypothetical imperatives say if you want to bring about this outcome, you should do this. Categorical imperatives say you should do this. So define both concepts and then just explain something about the difference between them, right? So you've given the definitions, but that's not yet explaining the difference. The difference is in how you can treat them, what needs to be the case in order for you to believe one or the other. So someone who disagrees with the goal or aim of a hypothetical imperative, that the goal of or aim of a hypothetical imperative is morally good, can still agree to it. So for example, if you want to harm the earth, you should pollute is probably true. It's a true hypothetical imperative, even if you think harming the earth is an awful thing to do. Yeah? So, I don't want to be repetitive here. You guys see what the kind of requirements are? I'll lay it out more clearly. This is one I didn't include because it's too much for just one of these questions. There's 3 concepts and you're supposed to relate them all. So I didn't. Probably you don't have to write this much. I mean, if you're stuck, just explaining anything that you understand that's related to the idea might be worth marks. So go for those part marks if you're stuck on something. It's always a good strategy. But so again, the best strategy: define the concept. So an analytic statement's one that's true just in virtue of its logical structure or the content of the concepts it uses. And then an example: it is raining or it is not raining is analytically true because of the content of its concepts. Sorry, that's not true. Because of the structure of its concepts. Yeah, that's worth a quarter mark off. Okay, so a bachelor is an unmarried man is analytically true because of the content of its concepts. That one's true. Okay, so that's enough of a definition of those 2 concepts. And you've given examples, so that's good stuff. A synthetic statement is a statement which is not analytic. Now we're doing the relationship between the concepts, right? It's talking about how they're related to each other. A contradictory statement is one which is false because of its logical structure or the content of the concepts. Again, a definition, and again, a little bit relating the 2. So the negation of an analytic statement is contradictory. The negation of a synthetic statement is neither analytic nor contradictory. Okay? So here's the general framework that I want you to keep in mind. So usually you need more than 1 or 2 sentences to get full marks on these. 1 or 2 sentences will be enough to define the concept, but probably not to explain it. But you do need to define the concept or concepts. Examples help. So if you define it and then give an example which fits the definition, that's a way of demonstrating that you understand the definition you've given. And relating the concept to 1 or 2 other concepts we've talked about in the course is another way of showing that you're able to synthesize different ideas, right? So, like, just memorizing a list of definitions doesn't give us much evidence that you're understanding the content of the concepts. But giving examples and relating it to other concepts does give us that kind of evidence, right? So that's how you show us that you're understanding. Yeah? I think that's all I had to say about the short answer questions. Is there anything else you want to ask about these things? Yeah.
In the last question, you said
think so. I think so. There's probably better ways you could have done it. So, like, okay, if you wrote all of this, I would say you should get full marks because you've really carefully defined analytic, and then you can use that, you leverage that definition to say, look, if it doesn't meet these criteria, then it's synthetic. Another strategy would be to say something about the fact that you usually need to check in the world whether a synthetic statement is true. So that would be a more independent definition. Yeah. They're gonna look at your answers and try to evaluate them holistically. Like they're gonna say, you know, given this whole set of sentences, does this person look like they know what they're talking about? And so there's not really much more rigid rules than that. In general, probably you'll get 1 mark for doing the definitions and 1 mark for extra explanation. On this one, there's 3 things that you need to define. So you've done a bunch of work, you've done a bunch of work to do the definitions, and like that should be worth a mark. Like those 3 definitions all put together should be worth at least 1 mark, right? This is a bit atypical as a question because I don't think I asked you to do anything with 3 separate concepts. That's a lot to both define and relate to each other for just 2 marks. But yeah. So, yeah. I think contradictory statements are also synthetic. I think that's true. Yeah, you don't necessarily have to relate it to another concept from the course. Giving examples is another way of explaining it, or like showing that you understand. Maybe another way would be to like draw out some of the consequences of your definition. So like, given that that's what it means, this and this follow. And you're really just exploring the concept more, but you're at least unpacking it a little and drawing it, showing you know what it means, really. Any strategy you can think of to show us that you know what these concepts mean should be good. These are just supposed to be examples of like ways that you can do that. Yeah. Yeah? So I'm really not trying to trick you with the questions on the exam. I really tried to make them central ideas that you should have picked up. If you've been listening and paying attention and focused and absorbing the material, you should do very well on this. And I'm counting on enough people to be apathetic and disengaged to generate a reasonable grade distribution. Don't let me down. You all are showing up to the final review class of your own free will, so you hopefully will all do well. But your absent classmates hopefully will, many be taking credit, no credit or something. All right. Further questions about this stuff? Yeah. Okay, good. So, yeah. Now we just have like a bunch of terms that we could talk about, and we could talk about any or most or all of these. We have 2 hours, so I suppose we could go through them systematically. I'm not sure how helpful that would be to you, though. Like, all of the lectures are online, so if you want to do a really thorough review, you can listen to the lectures. I'm told that the pace at which I speak works reasonably well at like 1.5 speed. So especially if you've heard it before, so you can just like zoom through these. I don't know. I'm probably going to ask you about arguments, given that arguments are the central concept in this course. The whole course has been built around trying to get you to know exactly what an argument is and exactly what makes it good. So I would have, if I was you, a ready answer to what is an argument and what makes an argument good. Strongly recommended. Yeah? And probably you need to know other concepts. So if you're going to answer that question, probably you need to know other concepts like premise and conclusion. If you're going to explain what an argument is, you probably want to mention premises and conclusions, right? This is going way back. Like this stuff, at this point in the course, you should feel that this is almost patronizing to even talk about this stuff because it should be so familiar. But, an inference, what's an inference? Yeah.
Is it like the unwritten thinking between 2 premises and its conclusion?
Yeah, it does. You can write. I mean, in some sense, every argument contains an inference, right? So an inference is just taking one bit of information and moving from that to another bit of information. Not all inferences are arguments because you can have an inference in a non-argumentative context, but like, it's really just taking one bit of information and using it to infer. You infer another piece of information. Yeah, it's the line. The inference is the line in an argument diagram. There's no chalk. You'll have to imagine the line. Between a premise and a conclusion, there's an arrow, and that arrow is your inference. And you talk about inference indicators. Recall that stuff from way, way back. So therefore, or because, hence, those are all inference indicators, and they show you that there's supposed to be an inference happening. Those would be good things to mention. Conditionals. Yeah, so we talked a lot about conditionals, and the conditional stuff is related to modus tollens, modus ponens, affirming the consequent, and denying the antecedent. That's probably good stuff to know, right? And know which of those are reasonable inferences and which ones aren't. Thank you. Yeah. Okay. So you recall that an conditional is one of these things. If P then Q. Very few things in life as satisfying as writing on a perfectly clean chalkboard. Oh, it's so good. Okay, so this is a conditional, if P then Q. Or you can just say P arrow Q. That's how they write it in symbolic logic. Right, and there's a bunch of inferences that you can make based on this, right? The 4 different inferences that I just mentioned. Modus ponens, modus tollens, affirming the consequent, denying the antecedent. 2 of those are perfectly valid inferences, arguments, patterns, and 2 of those are fallacies. So, here we go. Just write them all down. And try to name them and tell me which ones are the reasonable ones and which ones aren't. Okay, what's this one called? Everyone together now. Modus ponens, exactly. And is that a valid or invalid argument? Valid argument, good. That's the easy one. Okay, what's this one called? Affirming the consequent. This one's affirming the consequent. So if you recall, this part is the antecedent. Comes before, and this is the consequent. And just a warning, this itself is not an argument. This is just a statement, right? It looks like an argument because so if this then that, and you can build argument structures on it. This itself is just a claim. Okay, so in this one, what you've done is affirm the consequent. Now, is that a valid or invalid argument structure? Probably remember. It's invalid. So if I say, if it's, I always go to if it's raining then the sidewalks are wet. I should come up with a different one. If you're rich, then you're happy. You're happy, therefore you're rich. Clearly doesn't follow, right? Even if the first thing is true, which probably it isn't. But even if this is true, knowing that the consequent is true doesn't tell you that the antecedent is true, because there are probably other ways for the antecedent to be true. Yeah? So affirming the consequent, modus tollens, or modus ponens, that's good. Modus tollens, that's bad. Okay, this one. Denying the antecedent, and is that a fallacy or a perfectly reasonable thing to say? I think that's a fallacy. Yeah. Wait, no. Wait. No, this is the good one. This is the good one. Right, okay, so, no, that's a fallacy. No, that's right, that's a fallacy. You kind of have to think through them. Okay, so if you're rich, then you're happy. You're not rich, therefore you're not happy. That's wrong for exactly the same reason as this one was, right? So there's probably other ways to bring about Q than P being true, right? So unless P is this doesn't say it's a necessary condition for Q, it says it's a sufficient condition. So if P is true, Q's got to be true, but it doesn't say anything about what happens when P is false. Right? So inferring not Q, that's a fallacy. Okay, and that leaves this one must be okay. You already said the name of it. It's modus tollens, also a perfectly valid argument. So if it's true that if you're rich, then you're happy, and you're not rich or you're not happy, that means that you must not be rich. Yeah? So if this P is a sufficient condition for Q, right? If P is true, then Q's got to be true. And Q isn't true, that should make you believe that in fact P is not true. Yeah? Okay, so those are all the things you can do with a conditional, right? These are all the arguments that you can build using a conditional and either the truth or falsity of the antecedent and the consequent. Good? Okay, how about possible world and necessity? Those are related, right? Or all that. So what does it mean to say something is necessary? And a hint that you can explain this using possible worlds talk. Yeah.
That there is no possible world where, if P is necessary for Q, there's no possible world where P is not Q.
Right, good. You could probably say, so that was the conditional version, so that's what happens. So it's, and these are why these arguments are logically valid, because if this is true and this is true, then this conclusion is necessarily true. There's no possible world in which if P then Q is true and not Q is true where P is true. Yeah? So in general, something is necessary if it's true in all possible worlds, or true in all possible cases if you don't want to talk about the world stuff. That's fine too. Yeah? Or just that it's always true. You could be even simpler than that it's always true no matter what. Another way of saying is that you don't have to check the world to see whether it's true. Right? So if something is a necessary truth, lots of people think 2 + 2 = 4 is a necessary truth. And you don't have to go do tests to see whether 2 + 2 = 4 is right. You just know. Yeah? Oh yeah, and a categorical claim. That's the other one from here. So, and I remember we talked about how conditionals and categoricals are really similar sort of things. So all P's are Q, are Q's. So all humans are mortals. All cats are mammals. That kind of thing, yeah? And you can kind of translate between these. So if all cats are mammals, then if something's a cat, then it's a mammal. Yeah? They act the same. So long as the conditional is, or the categorical is strict, where it's always the case. All of the members of this category have this property. Yeah? So if I asked you a question, a short answer question about, for example, categoricals, you would tell me something about applying a property to a category. Say, all members of this category have this property. That'd be good for a definition. And then relating it to conditionals would be a nice way of bringing in another concept from the course and showing us that you understand both concepts. Yeah? Okay. Was there anything else in there? No. Fallacy? What's a fallacy? Yeah. An error in reasoning. Right. We talked about a ton of different fallacies. Okay. Is this helpful? Do you want to keep going through all of these? Okay, yeah. I'm happy to take the full 2 hours if you guys are. Also, don't feel obliged to stay if you're bored and have other things to do. It's okay. I would, yeah, this is, hopefully this will be run on a quite easy casual basis. Okay. Well, if you don't know what an independent and a dependent reason are, you're going to have a lot of trouble with the argument diagrams, right? Hopefully this is stuff that's been so drilled into you by now that you're bored with it. So 2 reasons are independent if, and this is another chance for you to bring in other course concepts. So two premises, you draw them like this. P1, P2, so those are P1 and P2 are independent premises leading to the conclusion, and they're independent just in case their relevance to the conclusion doesn't depend on the truth of the other one. Right? Relevance being another important course concept. So P1, if they're independent, P1, if it's true, raises the probability of the conclusion regardless of whether P2 is true. And the same for P2. It doesn't matter whether P1 is true. P2 is raising the probability of the conclusion independently. And of course, the dependent reasons are just the opposite. So in this diagram, P1 and P2 have to both be true for either to be relevant to the conclusion. And the classic example of this stuff is conditionals and categoricals. So I said before, you know, if you're rich, then you're happy, and you're rich, therefore you're happy. Well, the fact that you're rich is not relevant to your happiness unless that first thing is true, right? It's got to be true that those 2 things are related for your level of wealth to be at all relevant to the conclusion. Yeah? That means they're dependent premises leading to the conclusion. So, good things to mention in that, relevance. You might want to explain what you mean by relevance. Yeah? Give an example. This would be a really easy one to give an example of. So generate some example of an independent set of premises leading to a conclusion. And if you see just one of these, if you see independent reason, another strategy, a really easy way to relate this to another course concept would be to contrast it with dependent reasons. And similarly with dependent reasons. If I ask you about what's a dependent reason, say, well, it's like this, here's the definition. It contrasts with independent reasons that are like this, and here's that definition, and maybe one example, and that would be excellent. Yeah? Okay. Deductive and inductive validity. So, these are all deductively valid, right? These modus ponens and, oh no, sorry, not the ones with X's on, but the modus ponens and modus tollens, these are deductively valid argument patterns. Now, does that mean their conclusions are always true? No, definitely not. Because we're distinguishing validity from soundness, of course. So, what does it mean for something to be deductively valid? It means that if the premises are true, then the conclusion is guaranteed. Or you could say it's necessary, right? Necessarily true. Sorry, it's not independently necessary, but the truth of the premises makes the truth of the conclusion necessary. There's no possible world in which the premises are true and the conclusion is false. Yeah?
Did you say that the structure of the argument is
Yes. So in either inductive or deductive validity, validity is a feature of the structure of the argument, for sure. And it doesn't matter. So in this case, it doesn't matter what you plug in for P and Q. Totally irrelevant. The argument is still going to be deductively valid, if probably not sound. So like, if it's raining, the moon is made of green cheese, the moon is not made of green cheese, therefore it's not raining, is a perfectly deductively valid argument. The content is nonsense, right? It's clearly false content. No, it's not a reasonable inference in general, but it's got the structure right, so it's deductively valid. Yeah? Okay, so contrast that with, again, if I ask you about deductive validity, it would be a really good idea to contrast that with inductive validity, which is also a kind of validity, but it doesn't guarantee the conclusion, right? What does it do? It merely raises the probability of the conclusion, right? So it makes the conclusion more likely or more believable or something like that. Yeah? If I asked you to give an example of an inductively valid argument, what would you say? I give you a couple of examples of argument forms that were inductive. Like inductive generalization, for example. So if I say all observed swans had beaks, therefore all swans have beaks. That's an inductive generalization. Right? That's a kind of argument. So all observed x's have y, therefore all x's have y. Now, that's clearly not a deductive argument in that the conclusion is not guaranteed by the truth of the premises. Right? It could be that you just didn't look at all the swans yet. Or there might be swans in the future that have no beaks or something like that. So it doesn't guarantee the truth of the conclusion, it just makes it more likely. Yeah? Okay. Soundness, we did that as one of the samples, so let's skip that one. Logical strength. Logical strength, I'll just do this one because I think it's weird. It's a weird kind of question to ask. The logical strength of his argument is its degree of validity. Degree of validity, I think, is a good enough definition. So deductively valid arguments have better logical strength than inductively valid arguments because they guarantee the truth of the conclusion. But nonetheless, inductive arguments still have not zero logical strength, right? Logical strength is about, again, it's about the structure of the argument. Like, how good is this structure? Before I know anything about whether the premises are true, how does this structure relate the premises to the conclusion, and does it make it at least more likely? Does it make it completely certain if the premises were true? Yeah? Let's do belief bias. I think I put belief bias on here twice, so let's do that later. But missing premise. Let us talk about that, because there's a couple things that you should keep in mind about missing premises, especially on your argument analyses. So, I've got P1, P2, leading to the conclusion. Okay, does that make sense? No, why? What's wrong with what I just did there? Yeah. Very good. That's right. So the missing premises this is probably not everywhere in the world you go that will make this a rule, but we've made it a rule in this class that you don't add missing premises that just kind of float free as independent reasons. Missing premises have to be related to one of the other premises, and the reason that you add them in is to show how one of the premises that was stated is relevant to the conclusion. Yeah? And probably the most common thing that you're going to add in as a missing premise is one of these two things, a conditional or a categorical. Yeah? Because those are the most common things to be in this style of dependent relation. So why don't you just add in independent missing premises? Isn't that a nice thing to do? Aren't you helping? Well, maybe, but your job is not to, recall what your job is in argument analysis. It is not to reconstruct a better argument than they gave you, right? you're not trying to just give away logical strength, or you're not trying to just like help them as much as possible. Probably for most arguments, the best way to help them would just be to toss out their argument and make a better one. But that's not argument analysis anymore, that's just making arguments. When you're analyzing an argument, your job is to figure out the structure of what was written as best as you can. And you can do a little bit of reconstruction, you can do a little bit of fudging and moving stuff, but really the goal is to home in on what their structure is meant to be. And you do this with the principle of charity in mind. You know, you try to read it as generously as possible, but don't read so much into it that you're just adding to it yourself. Yeah? So, missing premises. These are premises that you need in order to make one of the explicitly stated premises relevant to the conclusion. Okay. Descriptive normative, we just did that, right? Okay, let's skip that. I think I mentioned Hume's law in the short answer one as well. So Hume's law just says you can't get, so here's another reason why you might add a missing premise. If this conclusion is normative and all of your premises are just descriptive, Hume's law says you're not allowed to get there. You're not allowed to get from just descriptive premises to a normative conclusion. Because why? Because descriptions just tell you how objects are arranged in the world, right? That's all a descriptive sentence can give you. I suppose you can describe mathematical facts or abstract facts as well, but descriptions just tell you how things are. Normative claims tell you how they ought to be, and the fact that things are a particular way doesn't seem to by itself give you that it ought to be some way, right? So you got to feed in normative premises to get out normative conclusions, and if you only got descriptive premises but a normative conclusion, probably you want to articulate some missing normative premise. Yeah? It may not nicely fit one of these styles, but like, but you know, like if you say, you know, oh my God, he's going to kill that guy. You should stop him. There's a missing normative premise in there that like killing people is bad. I guess that's a categorical, right? So acts of murder are bad. Yeah? Good. Good. Values. What did I say about values? If I asked you for a definition of values, what do you think a good answer would be? Are you? Oh, okay, yeah. Yeah. Sometimes a thoughtful gesture just looks like a hand up. I don't think I asked about values on the exam, to be honest. But it might be helpful for something else that I asked about, so. So values are a normative concept, right? Values are about what's good, or what you should do, or what you should want. And I believe the way I described them to you was that they're like big, stable meta goals, right? So they're goals about what kind of goals you should have. Yeah? So if I say, my goal is to fix myself breakfast, that's not really a values statement, that's just like your goal. But you have values that make that a sensible goal to have. Like, I want to keep myself alive. That's one of my values. So I'm going to have the goal of making myself breakfast. Or I want to be well-fed to do well in my day. Now, that's a value. And it's about what goals make sense to set for yourself. Right? And then ethical theories are supposed to be these theories, these abstract philosophical theories, that justify values. So why have you got the values that you've got? Why are those the right values? Should you have other values? Maybe. Maybe not. Maybe there's no justifiable ethical theories and people just have the goals they have and that's the end of the story. Some people think that. But if you subscribe to some ethical theory or other, then you believe that there's a fact of the matter about which values you should be holding, right? There's something that you should care about. There's things that you should value, and your ethical theory tells you which values those are. Yeah? Okay, so we talked about hypothetical imperatives and categorical imperatives already, and meta-ethics. So recall meta-ethics. So we had this like hierarchy, right? We had, you know, your goals, your values, your ethical theory, and then your meta-ethical theory. And like, I think I drew like a line here that said, oh yeah, in behavior. V or. So the stuff you do, everybody does stuff. I can tell by the way you showed up today that you do stuff. And the stuff that you do has some kind of sense and order to it, right? You don't just do random stuff. You have goals. And the stuff that you do is aimed at bringing about your goals. Which goals should you have? Well, you got values, and your values tell you which goals you should set for yourself. And I think I said, everybody's got these things. Everybody's got something below this line. Everybody has behaviors they perform, they have goals they're searching for, and they have values to structure those goals. Yeah? Not everybody has an ethical theory that they subscribe to. Some people do. Lots of people do. Like anybody with a religion's got one of these, right? Our religion standardly contains some ethical theory or other. Lots of people who aren't religious also have ethical theories. I'm not religious, I have ethical theories. So maybe you don't have one of these, maybe you don't need one. I think it helps. You probably don't have one of these. You probably don't care about this that much. This is mostly philosophers who care about this meta-ethical theory, but it's a question of like, how do you justify an ethical theory? Like how do you say which ethical theory we should adopt and how ethical theories are justified? And of course, some people who don't have ethical theories have meta-ethical theories. So for example, somebody who says ethics is all nonsense and BS, right? That's a meta-ethical theory. It's a theory about ethical theories. If I think all ethical theories are hokum and nonsense, that's a theory about the activity of constructing ethical theories. Most philosophers don't say that. They say that some ethical theories could be justified, or they have long arguments about it, but that's what meta-ethics is. I'm almost certain I didn't ask about meta-ethics on the exam, so don't worry too much about it. But if I asked you about any of these other things, these are all concepts that you could bring in to bear on explaining them. Yeah? Good. I promise you there are no questions about telling me whether a definition is too broad or too narrow on the exam. There are none like that. But you should know what analytic and synthetic mean. So what does it mean to say a statement is analytic? Yep. Exactly. Oh yeah, we did this in the short answer, didn't we? Okay, yeah, we did analytic and synthetic and contradictory in the short answer ones. Good. So, confirmation bias. This one I thought was important. So we did biases more at the end of the semester, but I mentioned this a few times because I thought it was really relevant to this course. Confirmation bias. Yeah.
Is that when you like the conclusion, so you like all the premises too, and you think it's a really good argument?
So that's more like belief bias. So this is belief bias is where you're like, well, I love these premises. Those are good premises. I love the conclusion. Great conclusion. Therefore, I believe that these inferences are good. Right? The psychological. Yeah.
Sorry, what about the analytic statement?
Oh yeah.
Would it be possible if we said something like its negation is contradictory?
Yes, so that's a good definition of an analytic statement. An analytic statement is one whose negation is contradictory. If you're going to explain it, you got to tell me what you mean by that. You got to tell me what a contradictory statement is and why negating one would end up analytic. But that is a good definition, right? It's a definition in the sense that it picks out all and only the analytic statements. You might give a different definition and then give that as a little bit of elaboration or something like that. But yeah, that's definitely a good thing to say. Yeah. Good. Okay, so biases, right? Belief bias. Belief bias is the one where if you're convinced of the premises, convinced of the conclusion, you're convinced that the inference is good. And the theory is people are like this, so that's an irrational thing to do, as we've been talking about all semester. You should distinguish the validity of an argument, right? Its logical strength from the truth or falsity of its premises and conclusion, right? why do people do this? The idea is that what you do, if you're evaluating an argument in a quick way, you don't have a lot of time, you just got to figure out immediately whether you think it's all right. What you do is you build a model of the world, and you say, can I build a model where this is true and this is true? I can? Great, good argument. Right? But that doesn't mean, just because you can do that, it doesn't mean that these things follow, this thing follows from these things. Anyway, so belief bias, and then confirmation bias is a slightly different bias. It's about which information you pay attention to. So it assumes that you've got a theory about how the world is, and then says people are much more likely to pay attention to information that confirms their theories than disconfirms it. Yeah. And that makes a lot of sense. If the space of possible theories is very, very large, that kind of makes sense as a strategy, because you're just looking for anything that can tell you that you're onto something. But nonetheless, not a good thing to engage in. Well, it's a thing we have to deal with. Right. Do I have to go over acceptability, relevance, and adequacy? I mean, you should be so sick of those ideas by now. So sick of them. How about empirical judgments and a priori judgments? Probably should go over those, right? So, okay, so an empirical judgment is one that you make on the basis of empirical data. Empirical data is stuff that you've observed, or like seen or heard or tasted or something like that, right? So it's based on sense information. It's based on your observations. That's your justification for the judgment is some observations or other, which contrasts with a priori judgments. There's too much Latin in this course. I'm sorry about that. A priori judgments, I've been socialized with philosophers for too long. A priori judgment, a priori just means from before. So from before you ever saw or heard or tasted anything, what do you know? What can you justify on that basis? Obviously, before you saw or heard or tasted anything, you didn't know anything, you were a baby, or maybe a zygote, but it's what you can justify from before you said anything about what you've experienced. What can you justify? So 2 + 2 = 4, you probably justify that without going out in the world and checking it, right? Or, if P then Q, P therefore Q, you can probably justify that without any reference to sense experiences. Right? You justify this on the basis of logical principles or something like that. And distinguish this from the psychology of how you, so to distinguish the justification of beliefs from the psychology of acquiring beliefs. Because you don't learn anything except through your senses, right? Like, that's the only way that anything gets in your head. If you didn't have sense experiences, you wouldn't have any thoughts. Like, you wouldn't be able to do, like, abstract math is supposed to be one of those things that's a priori. It's done, you don't learn math by going and do mathematical experiments. You learn math by, like new math, by doing deductions and thinking real hard. Like a mathematician at work is just somebody chewing a pencil and looking out a window, right? So that's how they generate new mathematical theorems. Nonetheless, you don't get to be a mathematician without like having a life and having a psychological process that got you there. So the beliefs that a mathematician justify or that generate are justified a priori because you don't have to test them against experience. They are generated by a psychological process that requires experience, right? So distinguish the justification of beliefs from the psychological generation of beliefs, okay? And that's, so these empirical and a priori judgments are based on the justification of these beliefs. Yeah. For our purposes, it's probably not that important what the difference between analytic and a priori are. Yeah, I didn't ask you anything about that on the exam. Okay, let's leave that aside. Induction. That's when you apply a current and it causes it to heat up. No, never mind. That's a different kind of induction. So induction contrasts with, why don't I have deduction on here? I should have deduction on this list because it's the opposite of induction, right? So deduction is where these are deductive inferences. Logically valid inferences are deductive because the truth of the premises guarantees the truth of the conclusion. Inductive inferences, these are types of inferences, recall, so inferences are moving from one bit of information to another bit of information. Deductive inferences move with certainty from the first thing to the second thing. Inductive inferences move with less than certainty, right? So it's an inductive inference. If I've, seen 100 cats with 4 legs, I say cats have 4 legs. It's an inductive generalization. Yeah? Stuff about generics. Does anyone remember? Give me an example of a generic statement. It's a type of statement. Yeah. 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 So that's a generic statement. Some P's have Q. It's a generality. You could also just say, so here's the weird part though. You could also just say, here's a classic generic. Birds fly. So some birds fly. Like the charitable way to interpret that is some birds fly, because there are birds that don't fly, of course. There's penguins and emus and ostriches. Right? So that's a generic statement, and you can read it as a general statement or a universal statement or an existential statement. So the universal, all birds fly, and the existential, there exist flying birds. So let's call that one the generic, the sort of medium, the general one. I'm not sure that that's exactly how it's used in the literature, but for the sake of this class, let's call that the generic. That's the sort of medium strength one, and this very strong universal claim, and then there's this very weak existential claim. There exist flying birds. Yeah? Okay. The criterial approach is just this thing that we're doing with acceptability, relevance, and adequacy. It's the contrast with the fallacies approach. So the criterial approach is about what makes an argument good. The fallacies approach is about what makes an argument bad. It's just the name for the style of argument analysis we've been doing. Inconsistency. So when is a set of statements inconsistent? Yeah. They can't all be true at the same time. Yeah. It's fairly straightforward. Good. Okay, now we're getting into fallacies. So appeal to ignorance. These would be really good ones to give an example of. And distinguish the fallacy from the legitimate argument pattern. Another really good thing to say. You could say an appeal to ignorance, such as, I'm not aware of any evidence that I'm a jerk, so I'm not a jerk. Well, if it's likely that you would be aware of evidence, then that's a perfectly reasonable thing to say, right? If you're the kind of person that just ignores that kind of evidence, then it's a fallacy. Right? Okay. Begging the question. Do you want to go through these in detail, or I feel like, nah. So just quickly, begging the question is using a premise to justify a premise. So if P1 is identical to the conclusion, you've begged the question. Or if P1 assumes the truth of the conclusion, they don't have to be identical, but it's just like, yeah, whatever. Yeah, you guys get it. Okay. Equivocation, treating two things that are different as though they're the same. False dichotomy, saying that there are only two options when there are more than only two options. Yeah? Stop me if you've got any questions about any of these things. Yeah?
So false dichotomy
Oh, sorry, yes, no. You can have more than two. Yeah, so if you say, look, your shirt has to be blue, black, or red, there's no other options, that's a false, it's still a false dichotomy. It should be a false trichotomy, but let's just call it a dichotomy for the sake of convenience. That's a good question, though, yeah. Yeah, okay. We already talked about inductive generalization, right? We just talked about that. Inductive syllogism. Okay, so if you're talking about inductive generalization and inductive syllogism, remember this stuff about going from, so you got a sample, and then you have some population of which the sample is a member. Inductive generalization goes out. It says, look, we looked at this sample, it's a member of this population, therefore the population is like that. Inductive syllogism goes in. It says, look, I know this fact about the population generally, so I'm going to infer a fact about the sample. Yeah? They're really just the opposite styles of, both are inductive arguments, both are different styles of inductive argument. Any questions about that? Okay. Inference to the best explanation. I'm TAing for another class right now, and the professor is just so down on inference to the best explanation. She just hates it. Thinks it's the sloppiest, most unuseful style of argument that you can think of. I think they're okay. They're okay. All right, so what's an inference to the best explanation? What's the structure of an inference to the best explanation? Yeah.
If P, then Q, so maybe P or...
Yeah, exactly. And that's this thing, right? Okay, but you can get a bit more, we can get a bit more charitably specific here. So it's not just any conditional, it's if my theory is true, then we should make this observation. We made this observation. So this has to be a theory. This has to be an observation. And then you say probably P. Yeah? So if my hypothesis is correct, this is what we'll see. Well, that's what we saw. So probably my hypothesis is correct. And so just that is a fallacy, right? That is not a good argument. I think this is why she hates it so much. She's heavily steeped in logic. That's a fallacy, right? What makes an inference of the best explanation not just a fallacy, not just a complete error in reasoning? Well, it's that it's the best hypothesis. So what you're trying to do is get this biconditional. You say, if and only if my theory is true, then this observation is, then you'll see this observation. I saw this observation, therefore my theory is true. Now that's a good inference, right? That's just modus ponens. Yeah, so it's just, the biconditional just says that the conditional goes both ways. So if Q, then P, and if P, then Q. So now, that's a fine inference. This is a fine inference. The problem is, of course, how do you know that your explanation is the best explanation? Did you think of all of them? How do you know you thought of all of them? What makes it the best explanation? Those are the kind of questions you might ask when somebody offers you an inference to the best explanation. I think I gave you the example of like, if somebody was stealing my money, I'd be poor. I'm poor, therefore somebody must be stealing my money. But of course, there are lots of reasons why you might end up not having all that much money. Yeah? So you haven't ruled out all the alternative hypotheses. Yeah?
Is the scientific method just an inference to the best explanation?
It certainly features in the scientific method. It certainly features in the scientific method. So we do things like this all the time. The best explanation for why we see the observations that we do is that electrons and protons and neutrons exist. That's our best. We haven't actually directly observed them, but we've got this theory. It involves electrons, protons, and neutrons, probably other things. It does a really good job of explaining everything that we see, so probably those things exist. And that, by the way, is the only reason that we have to believe in those things. because they do a good job of explaining stuff, not because anybody's ever seen one, right? Because you can't see those things. So all of the unobservable elements of science, like science includes a lot of like observable stuff, like, so those things are typically inductive generalizations. So you make a bunch of observations and then you make a generalization from that. But for anything unobservable, yeah, it's inference to the best explanation drives all of our beliefs that like, your belief that atoms exist is based on an inference to the best explanation. So hopefully it's not that bad of a method of inference, but yeah, could be better. Okay. Bunch more fallacies. Is there any more questions about that? That good? Okay, let's do some more fallacies. Will you be hurt if we don't do the argument analysis? I fear we're running out of time. I've posted it to the Blackboard, and one possibility is that you can do it independently, and then I'll post what I think is a good answer. Yeah? I don't know. Probably you're like me in that your gas tank is like on E already, and that we're draining the very last dregs of all of our mental and emotional energy. Okay. So, appeal to authority. This is supposed to be a fallacy, right? Or this is one of the things that can either be a perfectly legitimate inference or a fallacy. So make sure you distinguish those two. Don't tell me it's a legitimate fallacy. Tell me it's either a legitimate inference or a fallacy. So, a legitimate appeal to authority. What would be an example? Like, yeah.
The experts on something unanimously agree something, therefore it's true.
Yeah, yeah. So you should believe that giraffes have 4 legs because all zoologists agree that generally speaking giraffes have 4 legs. There's no debate, everybody agrees, it's their subject of expertise, and furthermore that it's perfectly reasonable that they would know about that thing. There's no question about whether they would be like stuck on the question of how many legs do giraffes have. An illegitimate appeal to authority would be something like some philosophers say time doesn't exist, so time doesn't exist. Because you only said some of them, like there's debate amongst them. Furthermore, it's not obvious that that's their job to declare on that, something like that. Or like, you know, my astrologer said Bitcoin's going to keep going up and up. Like, it's not their job. Furthermore, how would they know? Furthermore, you know, don't listen to astrologers, I guess. Yeah. Unless they're right, I suppose. Okay, ad hominem. And it's related, so there's an ad hominem and there's a subspecies of ad hominem that I dread trying to pronounce. Tu quoque. I don't know how to say it. You don't have to say it on the exam, so. So, ad hominem, what's the literal translation of ad hominem? I asked you this on the test too. Yeah.
Against you.
Yeah, against literally the man or the person, but yeah. Yeah, so against the person. And it's where you say, your argument is wrong because you're a bad person. And that is not correct. Right? Well, so distinguish ideal rationality from rhetoric and being convincing and like compelling and all that stuff. So you believe people more when they're good, morally sound people, when they are consistent in their beliefs and their actions. And that's, I think, a perfectly reasonable thing to do. Like, there's no problem with like picking and choosing who you're going to listen to based on whether they seem like okay people. But it doesn't, just because someone's a bad person doesn't, strictly speaking, make them wrong. Bad people can say true things and make good arguments. Yeah? So saying you're wrong because you're a bad person is not performing ideal rationality. In pragmatic contexts, it might be good, right? So like, look, you've been just lying and lying to me. You've been deceiving me at every turn and manipulating me. You know, you stole my shoes and kicked my cat. I'm not going to listen to you anymore. That's a pretty reasonable practical inference to make, right? Like this person is just so toxic that I don't even want to involve myself with them. That's a very reasonable thing to do. But in terms of the strict logical structure of arguments, even that person that kicked your cat might give you a perfectly valid argument with true premises. Yeah? So it doesn't make their argument invalid, but it might mean that you should not talk to them anymore. So, so distinguish those things. And tu quoque is just the you too fallacy, saying, well, you told me that this thing was bad, but you do it too. I think the example was smoking. So it's perfectly reasonable to listen to a smoker who says, don't start. Right? They do it too, but they might well know better. Right? They might know more about the situation than you do, having fallen into it themselves. Yeah? I think I'm sorry, when we were reviewing the test, I think I slagged on my father was a smoker and then he's a jerk. My father is a smoker, and he says don't start, and he's right? So, okay. The balance fallacy, plague of modern journalism. Well, we've heard the anti-Nazi argument. What about the pro-Nazi argument? We've got to have both for balance. No, you don't. No, you don't. You need balance when there's two legitimate sides of an argument, right? If you're a Nazi and I hurt your feelings, good. Okay. Because you don't have a valid position in the discussion. You don't get your voice heard if you say something that's just obviously false and wrong, right? The balance fallacy is the fallacy of assuming that for any issue there's two sides of the issue, and there just aren't. Sometimes there's only one reasonable thing to say. Well, we've heard the 2 + 2 = 4 argument. What about the contrary? No. That's not a discussion you need to have, right? Okay. And the fallacy thrown in just for jokes is say, because somebody's committed a fallacy, they are wrong. And that's itself a fallacy because, so here's a fallacious argument. If P then Q, not P, therefore Q. Does that mean that not Q is false? Not necessarily. Not necessarily. It just means that this is a crappy argument, right? You can give terrible, terrible arguments that make no sense and draw on false premises and don't have good inferences in them for a true conclusion. Yeah? So just because somebody's committed a fallacy doesn't mean the conclusion of their argument is false. It's a reason not to believe that argument and not to take it into your way of thinking and seeing the world. But, yeah. Okay, good. And non sequitur, this was the just does not follow. I didn't give you this one because I thought it would be helpful. I thought I'd give it to you just because you should know these words, because Latin has been weaponized. So non sequitur does not follow. All of these, any fallacy is about whether one thing follows from another, right? So basically any fallacy is a non sequitur. If you don't know what fallacy it is, or if you can just if they're not, so you have to be making at least a little bit of sense to commit a specific fallacy. If you're just making no sense at all, there's no structure to your argument, then you can just call it a non sequitur. Yeah. Okay. Slippery slope. Again, this is one where there's a perfectly legitimate inference and there's also a fallacy. And roughly the structure goes, if A then B, if B then C, if C then D. Or just if A then B. And if those conditionals are less than certain or highly questionable even, then A doesn't always lead to B and B doesn't always lead to C and so on, right? If those conditionals are good, then it's not a slippery slope fallacy, it's a genuinely slippery slope. Okay. Post hoc, that's short for post hoc ergo propter hoc. after the fact, therefore because of the fact. So it's just saying like, you know, if you say, well, this happened and then that happened, therefore they're causally related, that's not necessarily true, right? So, you know, I got a haircut and then I won the lottery. Therefore, haircuts make you win the lottery. No. Okay. Spurious correlation. What's that one? It's kind of like post hoc, actually. It's kind of like post hoc. It's slightly more specific, but this was, yeah.
Well, two things have the same correlation, but that doesn't mean that they're related.
Right, exactly. They can be correlated, but not causally correlated, right? So you can have two things that are tracking each other really well, but nonetheless are unrelated. My favorite example is, of course, rising global temperature and the decline in Caribbean sea piracy. So as Caribbean sea piracy declined across the 19th and 20th century, the global average temperature has been rising. But those are not, one is not causing the other as far as I can tell. Good. And common cause, this is just where you think one thing has caused another. So you think A has caused B, but actually C is causing both A and B. So this isn't real. Yeah. I'm almost positive that's not in the exam. Okay. Right. After test 2, we should go through these ones. So, be able to tell me what cognitive biases in general are. Some little story about what is a cognitive bias. We talked about belief bias. We talked about confirmation bias. Does anybody remember what framing effects are? I told you this silly little story from the Zhuangzi about it. So, framing effects are the tendency for the way information is framed to influence the way you process it. The example I gave you was, people are happy to hear that a medical procedure has a 95% success rate, far less happy to hear that it's got a 5% failure rate. They're much less happy with undergoing the procedure if they hear it framed in terms of its failure rather than its success. Yeah? And this is why they put one really expensive item on the menu, to frame the prices for you in a different way, right? If the range is from $8 to $12, that you experience those prices differently than if the range is from $8 to $45. Okay. And all of these cognitive biases, I tried to make an argument that they can be explained in terms of error management. So that was the big argument from the cognitive biases lecture. Error management is this idea that you are a less than perfect reasoner in a less than perfect information situation, right? So you don't have all the relevant information almost all the time, and you don't have all the processing power you might want. Therefore, you're gonna make mistakes some of the time. So the strategy is to try to commit the kind of errors that are not that costly and avoid the kind of errors that are extremely costly, right? And this is the kind of thing that they specifically design smoke detectors to be like this. Smoke detectors go off all the time. They have a very low rate of successfully identifying your house being on fire, but that's a good thing. You want them to be on a hair trigger because it's much more costly to think that there's not a fire when there is one than to think there is a fire when there's not one. One is slightly annoying, one is the death of you and your family. So you want your errors to be managed in this way, right? And what I tried to argue is that basically all of these biases, or a lot of these biases, can be explained in terms of error management. Why are we wired up to make the kind of mistakes that we do? Well, it's because we skew towards making the cheap mistakes and away from making the costly mistakes. And if you can figure out what's cheap and costly in terms of these errors, then you can manage them. And that was the basic idea. Okay. The outgroup homogeneity effect. Remember that one? You can kind of piece, if you know the words, you can kind of piece it together. Yeah.
It's when you think your group is more diverse than another group.
Exactly, exactly. So people tend, if you have an in-group and an out-group, people you consider your people, and then people you consider not your people, people overwhelmingly tend, even if they're just the same, so the example was a sorority, different sororities, like really not, I'm sorry, you're all wonderful, unique individuals, but like any group of 30 undergrads is going to be fairly the same. You're all in the same city, you're all in the same age, you're all in the same income bracket. Like you're not that different. But along many things, you're very special and unique. Okay. But they will judge. We're not talking about people from like wildly different parts of the world or wildly different life experiences. We're talking roughly the same group of people. They'll judge people in their sorority to be more different from each other than people in the other group. They're like, they're all kind of the same, but we're all super special and different. Okay, so that's the out-group homogeneity effect. And you can think about it in terms of error management, like you need to care about the differences between the people that you interact closely with. You probably don't need to think about the differences between the people that you're not interacting closely with. So an error in one way is more costly than an error in the other. Black and white thinking, which I suggested was related to the false dichotomy fallacy, right? So black and white thinking says, either I get what I want or my life is a disaster, right? Either I get an A+ or I'm a failure as a human. That's black and white thinking. If you just got an A, that's not being a complete failure as a human, right? You still did quite well. And people tend to like, and I suggested that under more and more stress, the more stress you're under, the more apt people are to simplify their world into black and white, right? Because it's easier, it's mentally easier to deal with than all the shades of gray that come in between. So black and white thinking, it's where you kind of do a false dichotomy on the world, right? You're saying like, look, it's either this or that. Either I'm the most important person in your life or you hate me. And not allowing there to be any kind of in-between space. And that's a false dichotomy, right? Okay. There's a bunch of optimistic biases, a bunch of pessimistic biases. I think we're running out of time, so maybe we just sort of, well, not that much running out of time. So an optimistic bias is one where people tend to think that they're better at something than they usually are. Like 90% of drivers think that they are above average. Yeah. Something to keep in mind on the roads. Yeah, people tend to think that their kids are better than average. People tend to think that their marriage is going better than average. And you can explain these things in terms of error management. So if I ask you about this, a good thing to do would be to mention one of the optimistic biases, maybe relate it to error management. That'd be a good strategy. Similarly, pessimistic biases, variety of biases where people think that things are going worse than they actually are. So if you're feeling socially insecure, people will tend to judge little social gaffes as much worse than they actually were. So, well, much worse. They judge them as being more severe than the people around them judge them. And they judge them more severe than somebody who was more socially secure. So if it's your first time in this group and you do something a little dumb, you're going to perceive that, you're going to think everybody in the group saw it, everybody cared, they're all going to remember I did this stupid thing, right? Whereas if you've been in that group for a long time and they kind of accepted you and you know that they like you, you do some stupid thing and you'll have a much more realistic assessment of it. You'll be like, well, a couple of people saw that, they might have thought it was dumb, but it's no big deal, that kind of thing. And again, this is explainable in terms of error management, right? It's a big problem, like if you're trying to get your way into a new social group, offending people or hurting their feelings or doing something inept can be a big problem for you. Whereas if you've already got their acceptance and stuff like that, it's less of a problem. Yeah? Okay. And then we're on to the final thing. Oh yeah, so, okay, you've made it this far. I made a mistake. I told you last class that there was only one specific paradox I would ask you about. That was false. I looked at the exam again. I will ask you about Zeno's paradox of motion and the Sorites paradox. Okay. I've included there were a bunch more paradoxes in that class, and I included them on the list of key terms, but none of the other specific paradoxes are on the exam. Yeah? So you should know what a paradox in general is, and perhaps why they're a problem, which you could explain using the principle of explosion. So paradox is what? Yeah.
Two things are true?
Yeah, when it looks like two opposite things are true. I mean, two things can be true and that's not a problem, but yeah. Two things, it's something, there's a good argument for why it's true and a good argument for why it's false, and they look like they're both good arguments. And distinguish that from a contradiction, which is just like A is true and A is false. Like, that's just false, right? You just say, there's no problem, you don't have to think A is true and A is false. Ooh, is that true or is that false? No, that's just false. Whereas a paradox is something where it really looks like it's both true and false. And that's a problem because of the principle of explosion. Because you can do the following. Here's a logically justified inference. This follows all of the rules of logic. So P and not P, right? From that you can, of course, infer P, from which you can infer P or Q. And then you can use a disjunctive syllogism. So you can also infer not P. You can use a disjunctive syllogism from P and not P, or P or Q and not P to infer Q. Ta-da! So from a contradiction, we've derived some random Q. And that Q can be anything, anything. So if you accept that this is true, because you got a good argument for P and you got a good argument for not P, you can pull P out of it, and then you can always infer from P, you can always infer P or Q. And of course, you can also get not P out of this. And from P or Q and not P, you can get Q. So any random thing that you want can be inferred from a true contradiction. And that's bad. That's why you don't want to have paradoxes in your belief system. Okay. So that was paradox, principle of explosion, Zeno's paradox of motion. You recall? Oh, you answered all of them. Does anybody else? Thank you, by the way, for participating in class. Does anybody else want to do this? Yeah.
So Zeno's paradox of motion is Achilles is racing a tortoise,
Yep.
but he gives the tortoise an head start.
Yep.
So at T1, Achilles is further behind the tortoise, but when he reaches the tortoise T1, the tortoise will be at T2, and when he reaches the tortoise T2, the tortoise will be at T3, and so on and so forth.
Good.
Therefore, Achilles will never reach the vertical that level pass.
Good. So it's like this. Achilles starts here, tortoise starts here, and they start going at the same time. So Achilles gets to here, but by that time the tortoise has got to here, so Achilles has to catch up, but the tortoise has moved to here. Achilles has to catch up, and the tortoise has moved to here. Achilles has to catch up, the tortoise has moved to here. Yeah? So that's Zeno's one. Technically, I put it in the singular here. Technically, this is one of Zeno's paradoxes of motion, but we'll just call it Zeno's paradox of motion. And the Sorites paradox. This is the one about baldness and heaps. Recall this? So it starts from the principle, taking one hair off my head does not make me go from being not bald to being bald. So I take one hair off my head, principle is still true, right? So you can take another hair off my head. Principle's still true. Take another hair off my head. Until you've taken all of my hairs off, and according to this paradox, I am now not bald. But of course, a person with no hair on their head is a bald person. Paradox. Okay. And there's the heap version as well, so 1 grain of sand is not a heap. Adding 1 grain of sand to something that's not a heap does not make a heap. Add a grain of sand, add a grain of sand, add a grain of sand. Eventually, you're up to your knees in sand, but you're still calling it not a heap of sand because the principle applied over and over again will let you get there. Yeah? Okay, so those are the two paradoxes I'm going to ask you about. And so tell me the paradox. One way of showing that you understand it would be to tell me something about the resolution to the paradox. Yeah? How do you get out of it? That would be a good way of demonstrating understanding. Yeah? And if you don't remember what I said about those, the video is online. Okay. Okay, oh yeah, so we only got 15 minutes left. I don't think that's long enough to do a whole argument analysis. Is it okay if we leave this for another day, or there are no more days? Tell you what, so this is on the blackboard. Take a shot at this, and I'll post what I think is a good answer. I have the eerie feeling that we've done this one before. I think that's false, though. I think we just did a different argument about vegetarianism. Does this look like so familiar that you think you've done this one before? No, okay, good. Yeah, I think we just did a similar argument about vegetarianism. Yeah. Okay, thanks everyone. We'll see you at the exam, yeah. Or in my office hours. Yeah.